My name is Eric Deason, and I am the Eastern Regional Sales Manager for FLIR United States. I want to welcome you all. I know we've got folks from a lot of different time zones, so morning, afternoon, evening, whatever it may be. Also have Matt Batoy on board, and Matt's going to help out with questions as we go through the presentation. As we go through the presentation, if you have a question that you want to ask, we just ask that you use the chat feature to go right ahead and place that question in the chat feature, and Matt will handle some of those, and then we'll have some that may be left over at the end, and then we'll have an additional time at the end to do question and answers at the very end of the presentation as well. So again, want to welcome you and thank you for joining us. We are Teledyne FLIR here to talk about achieving vulnerable road user safety goals by using the Teledyne FLIR thermal-based sensors. So I'm going to jump right in. So we are part of the intelligent transportations of Teledyne FLIR. We do video detection and monitoring solutions for the traffic applications. The FLIR ITS is revolutionary in how traffic flows on roadways throughout the world. Our unique field-proven solutions help keep vehicles, pedestrians, and bicycles moving safely and smoothly. We have several different areas that we actually have equipment that we can support, such as the public transit, both in trains, railways, as well as buses. We do equipment in tunnels, sensors there for automated incident detection, volume, occupancy count information. Also on roadways, or what we might call in the United States interstates or highways. And there, those would be, again, automated incident detection, speed, volume, occupancy, collection data. And in the urban area, where we're going to focus today mostly on, is what we would consider signalized intersections or in metropolitan areas throughout the world. So 3 key takeaways that we want to make sure we cover with you today. And the first is dynamically and intelligently accounting for your vulnerable road users at the signal and at crosswalks. Secondly, we want to make sure that we're getting ready for connected vehicle initiatives today and in the future, and talking some about how we can support that. The third piece we really want to talk about is how Teledyne can FLIR vulnerable road user solutions can play a role in assisting you in your next project that involves vulnerable road users. So when we talk about vulnerable road users, there really are several types. Obviously, we begin with bicyclists. We then also have elderly folks or folks who may have a slower gait or walk speed. Parents with children themselves. And of course, those with particular limitations in their mobility, and how do we account for all of these at the same time? So some trends that aren't good for us for deaths here in the US, considering vulnerable road users. The Government Highway Safety Association's 2020 report listed 6,504 pedestrians killed by vehicles last year, which is a 21% increase over 2019. Interestingly enough, as we all know, we were in a pandemic. So overall vehicle miles traveled and number of folks on the highways was decreased, yet at the same time, we had an increase in pedestrian deaths. And pedestrian deaths as a percentage of the total motor vehicle crash deaths increased by 12% in 2009 to 17% in 2018. It's an increasing trend. Some quick facts that kind of help support some of the things we're going to talk about and where some of these challenges lie for you as designers is 75% of fatalities happen after dark. 4% happen at non-signalized intersections. And 63% happen at non-freeway arterials, our secondary routes, those roads where typically the speeds are slower and the majority of the pedestrians are actually traversing. So there's a lot of things that we do from a traffic engineering perspective to increase the vulnerable road user safety. The first is through designs. Obviously, dedicated bike lanes, getting those vulnerable road users, those bicyclists, out of the same lane as vehicles, obviously are going to help. Road diets and lower speed limits, those are increasingly being used more and more, especially in our large urban areas. Different type of crosswalks, Z patterns and raised crosswalks, so we really can identify where the pedestrians would be. Intersection median barriers and also safety islands are becoming very popular. And then, of course, advanced yield or stop lines, trying to separate that distance between the vulnerable road users and the actual vehicles on the roadway. Other areas that we take a look at in terms of our designs is visibility, marking enhancements, the type of material that's used, the retroflectivity of the equipment and things that are used. Lighting and illumination. Obviously, 74% of those deaths took place at nighttime. So there was most likely lighting and illumination issues. And of course, pavement markings, different types of markings, in-ground markings, all types of things. Signage is another thing that we try to improve, and the more information that's available for the drivers to be aware they're pedestrians or bicyclists in the area. And of course, we also look at our RFBs and hawk signals as options. When we take a look at technology, this is kind of where we at Teledyne FLIR fit in, where we believe we can help you in your designs and your applications of making the roads safer for your vulnerable road users. So passive and dynamic thermal detection sensors. Because of those sensors and their ability to really detect, and we'll get into details more about that as I move on, we're able then to provide that information and take advantage of some of the advanced traffic controller functionalities that have been designed in over the past few years to account for vulnerable road users. And last but not least is the V2X applications. Although there's a lot of discussions about what that ultimately is going to be right now, we believe our open architecture and the way that we provide the detection of those vulnerable road users really does support various different types of vulnerable road users, V2X type applications. So when we talk about our thermal images, how does it work? So a visual image and a way a visual camera works, which we also have visual cameras, we just feel for vulnerable road users, the best approach is the thermal device. So that visible light, that light that's out there shines onto that vulnerable road user and then back to the camera image to actually determine that it's there, detect, and see. When it comes to thermal, we actually take the light source or the heat or thermal image that's being created by the vulnerable road user, and we send that directly to the camera to place that detection. Some other ways that thermal versus optical kind of differentiates a little bit. Thermal works at night and in complete darkness. As you can see by the pictures on the very bottom there, traditional video cameras typically need, for vehicle detection, that light source, those headlights, to be able to see. But because we're looking at a thermal image, what we're able to see is actually the vehicle or that person quite clearly. Through headlights, shadows, and sun glare, those top pictures give you a prime example of the same intersection. And very typical, certain times of the year in east to west routes, this is a major issue. The sun shines and kind of blinds the entire intersection for a visual camera. As you can see there with a thermal image though, really it doesn't bother us. We see the sun as a spot of heat, but we really don't bleed out throughout the entire intersection. And then of course, those leaves or shadows that typically cause problems with a visual type of detection, not an issue for us because we're actually picking up again that thermal image. So the first tool in your toolbox, so to speak, for our vulnerable road users is our Trafi One. It's a 24/7 detection device, very reliable, low maintenance, that uses thermal imaging. We also have the ability to take that thermal image and send it back to a TMC or somewhere else to use that thermal imaging for monitoring to verify that we're seeing what is there and how it's working. A flexible architecture system as well. Every one of our Trafi ones out of the box comes ready for PoE, Ethernet, or basic power line 2, or what we call BPL2 communications. There's a Wi-Fi built in for setup and also to collect data for travel time. And the web interface, everything is done on the edge with our sensors that we're talking about today. So the actual setup interface is on the device itself. It's done through a HTML type of GUI. As long as you have ability with any device to talk to the internet, we can use this to set it up, which means for you in the field, no need for special software to set up the equipment. It's already on the device. It also has a tilt sensor for easy calibration and setup. And last but not least, we also have a visual HD camera, which can be used for visual surveillance, where that stream can be sent back to a TMC or somewhere else to see an image that you're probably more comfortable and familiar with in terms of a color video image. But remember, the thermal image is actually what's doing the detection with the Trafi 1. In terms of applications for the Trafi 1, we have signalized intersections, which would be obviously pedestrian detection, pedestrian counts. We could also do bicycle counts as long as they're in the crosswalk area. Output to the signal controller then, those outputs of what we see, which allows us to provide calls for a standard walk or even calls for an extended walk. When we talk about mid-block applications next, those of course are your RFFB, Hawk signal crossings, you know, what a lot of folks are calling a hybrid crossing nowadays. Bicycle trails, pedestrian detection and counts in that mid-block area. And then we can output that to a beacon, of course, an RFFB system to actuate. The beautiful part is the lights will only be on when the PEDs are in the crossing or waiting area. It's basically a contact closure. It's on or it's off as long as there's something in the zone that you set up. So when we talk about the different types of detection that we do with the Trafi 1, of course, number one is presence detection. We're noticing that something is there, a person or a bicycle or whatever it may be, that we need to actuate something, be it in this particular instance, let's say, working with the PED button to place the call that the pedestrian's ready to cross. Waiting presence, and I'll show a picture here in a moment of how that works, but it basically gives you the ability to determine what is there and how much is waiting. Directional presence, because of our tracking capability in our Trafi 1, we're actually able to determine what direction are the vulnerable road users traveling. Are they traversing the sidewalk or are they actually heading towards the crosswalk? We also filter out all the vehicle traffic that comes through the detection zone. We're only looking for vulnerable road users. Also gives us the ability to do zone counts and occupancy. And that gives us the ability actually to place the call based on how much of the zone is occupied. So let's say you were at a location, maybe at an arena or somewhere where there would be large crowds at times. You don't want to place that call necessarily when one or two people show up all the time. You want to place that when there's enough folks to fill a large portion of that zone. And that's user definable, 3 different settings that we can put together there. And then it'll place the call upon that. And then we also do line counts with the Trafi 1. Extremely accurate in 1-2s, but when we get into larger groups, those numbers drop, but it's still a very good, reliable number to give you some idea what's taking place. So we talk about prioritizing pedestrian safety. The waiting presence is one that I was mentioning earlier. This is an example of what a waiting presence zone would look like. And we can establish how much of that zone do you want to be occupied before you place a call, or how much do you know is how much is there? What is the zone full? Crossing pedestrians. This is an example of what you'd see with an image with a crossing pedestrian. Those little white hot spots are actually the pedestrians. And we would hold that call as long as they're in that zone, thus providing safe travel for the vulnerable road user. This is an example in this video of how we can do directionality. Now, of course, you wouldn't set a traditional zone up like this, but you can see as the people cross through, they're going in their proper direction, we would pick them up. We still see them, but they're not being calls being placed here simply because this is done, you know, obviously as a directional zone, just as a sample of how directional works. Ped call cancel is a feature that we offer. Although many parts in the United States don't allow for a PED to be called, it needs to be locked. We do have the ability to actually cancel the call or drop that contact closure to open once there's no one any longer in the zone. Dynamic clearance times is something else we can provide. Extend or shorten that pedestrian time based upon, is there someone in the zone and we need to hold it. This particular feature is used in Georgia in an application where we went to an all red and held all red as long as someone was in the zone after the PED time had cleared. Just an example of how we can make it much more safe for the VRUs in that area. And in priority calls, giving the pedestrians a head start on a side street pedestrian crossing so that if that was a phase that was going straight but possibly making a right turn, would be able to see that there's someone in the crosswalk before they make that turn. And of course, mid-block applications, probably the strongest suit of what we do because of the flexibility of turning that call on and off. Hawk signals, we know, reduce PED events by 69%, and RRFBs increase motorist yielding from 18% to 88%. I actually have a success story I'll share with you on that. So this is the success story that we had actually in my neighborhood, interestingly enough, with an RFFB and a crosswalk application. So the challenge and the issue was the crosswalk was put in with an RFB and a push button actuation. You see the apartments on the far side of this picture. Down to the right, about a quarter mile, is also a high school. On the near side, where the picture shows where you'd be standing, is actually a McDonald's and a 7-Eleven gas station. So there's a lot of pedestrian traffic across this. What was happening is students, runners, or bikes were not pushing the push button, or if they were pushing it, they may cross before the RFFB stopped flashing. I'd seen it personally with my own eyes. People would drive up, go, oh my gosh, there's no one in the crosswalk. This must not be working right. And next time they went through, they would just drive through. So the solution was for us to provide 4 Traffi-1s installed to actuate the system. The Traffi-1s actuated based on presence. On the sidewalk directionality, as we talked about, once they made a movement here towards the intersection, we placed the call. And then the Traffi-1s holds that call while the pedestrian's in the crosswalk. And once they're actually all the way to the sidewalk to ensure they're totally clear, then it would drop the call and the RFFB would turn off. Again, personally seeing it work, people now are noticing if that light is on, there is someone in or around that crosswalk they need to stop for. It's been very, very effective. The next tool in the toolbox would be our TraffiSense for vulnerable road users. It's an integrated thermal sensor as well. Has the ability to detect vehicles and vulnerable road users at night and over long distances and in harsh weather conditions. So for example, if you had a situation where you were on a bike path and you wanted to pick the bicycles up ahead of an RFB or a flashing beacon, we can actually, because of the capability of this, which is designed primarily for the traffic market for detecting vehicles, but can detect pedestrians, we could use this on a extended distance, which would give enough time to place the call before a bicyclist at a high speed would reach the crosswalk and place that call. Obviously then would make it the same type of application where it would hold that call until the pedestrian or the bicycle is able to cross the crosswalk. Again, this comes with Wi-Fi data collection capability, which gives you the ability to collect travel times. Most folks are walking with their phones. We could actually, if it was a large area, tell, from one location to the next who and what is traveling there and how, what is that duration between those crosswalks. Also, this sensor comes with the same flexible architecture as the Trafi One, a PoE, Ethernet, or BPL out of the box. No need to order a specific one, any one of those applications, depending on how you wire and set it up. Easy installation and setup again on this. We have that Wi-Fi with cybersecurity. Because Teledyne FLIR does a lot of government business, cybersecurity is extremely important to us. This also has auto calibration with the tilt sensor and low maintenance and overall cost of ownership, simply because of the thermal lenses don't need to be cleaned anywhere near as often as a traditional visual video lens would. This is an example of bicycle detection and counting that we would use on a roadway, for example, with other traffic. You'll see where we actually pick the bicycles up. We determine that they're also turning. This is very good example of what a single lane roadway would look like with all the different type of things that would be taking place on it. You see here, we actually detect and see that there's a pedestrian going across there, but we don't have pedestrian zone set up to detect them. So he's ignored as he runs across because this application is only set up to really identify the bicycles in the traveling lane. And last but not least, one of the things we talked about is kind of a takeaway is getting ready for connected vehicle initiatives today and in the future. As we mentioned, we really don't know what that's going to be in the future. Everyone has an opinion, and some may be right, some may be wrong. But the beautiful part is we've actually established a system because of our open APIs to allow you to pull the data directly from the device into your own system, be it whatever it may be. So this is a success story that's going underway right now. I was in New York City a couple of weeks as we were doing the installs in this location. This is right outside the Barclays Arena. You can see very unique angles and very unique sizes and shapes of the detection zones. This is in Brooklyn. So the project goal was to be able to detect the pedestrians in the crosswalk, provide that detection information to a traffic controller that someone was present in the crosswalk. New York City has developed their own in-house application that sends that pedestrian data to the RSU, then onto the OBU. And then they have 2,700 vehicles in the city that are New York City vehicles equipped with OBUs that receive an audible pedestrian alert. And it was just kind of a pilot, the proof of concept to verify this could be done. And we've been very successful. There were some challenges, however. As I mentioned, Flatbush and Atlantic Avenue and Barclays Center. The project challenges were, as you saw, the size of the crosswalks and some of those angles. And of course, crushed or blocked conduit, very common in a lot of our older urban areas, which didn't allow for the power of data transmission that we normally would set up back to the cabinet. So what we're able to do was determine we could get power from each of the poles that the Trafi ones were installed on. We needed multiple Trafi ones to make the project work. And then our distributor in the area developed and provided a self-contained wireless solution that would take the contact closures from the Trafi one, transmit them via a wireless solution over to the cabinet, and then once that data was in the cabinet, down to the controller, where it then could be sent out via the New York City application. So right now that's up and running. They're very happy. We anticipate that this could be a much larger, probably not citywide, but a very large portion of the major boroughs and close to the Manhattan area. So kind of in summary, everything we've talked about, We really feel that thermal detection provides the most robust and accurate detection for vulnerable road users. Because of that, no need for light and those other things we've talked about. Once you have the effective detection, which we believe we provide to those vulnerable road users, you can then service them more efficiently. Some of those ways, more efficient PED clearance times, bicycle specific signal phases, vulnerable road user data and detection for connected vehicle applications, and thus providing safer travel for your vulnerable road users.